With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So in this question it is given that we have to consider the atomization of bromine gas. According to the reaction, bromine dissociation will give us 2Br gas. Given that antilog of minus 7.02 is 9 into 10 raised to minus 4. If the heat of atomization of bromine gas is 82 kilojoule per mole and standard molar entropies of bromine gas and Br2 gas are 175 and 245.4 joule Kelvin inverse respectively, we have to calculate the degree of dissociation when the total pressure is 40 atmosphere at 500 Kelvin. So to begin with, we have to also assume over here that alpha value is very much less than 1 in our calculation. So to begin with, first what we'll do, we'll write down the reaction which is involved in this case. So the reaction is Br2 gaseous in equilibrium gives 2 bromine atom gaseous. To this, it is given that delta H naught is equal to 82 kilojoule, which can be written as 82,000 joule per mole. Now, initially, what we have is A moles of bromine. So, we will have 0 moles of this one. After equilibrium is reached, that is T is equal to T equilibrium, we will have how much? A minus X. So, here we will have 2x moles of bromine. We know that alpha, that is the degree of dissociation, will be equal to x upon A, where x is your number of moles dissociated and A is your initial moles. So, we can substitute the value for x is equal to A alpha. So, putting this value over here, we will get A minus A alpha and 2x will be 2A alpha. Okay. Now, if you calculate the total number of moles involved in this, it will come out to be A minus A alpha plus 2A alpha, which comes out as A taking common 1 plus alpha. So to begin with, what we can do is first write the entropy value, that is delta S naught H will be equal to 2 S naught Br minus S naught Br2, which will come out to be 2 into 175 minus 245.4. So from this we can calculate the delta G naught value as delta H naught minus T delta S naught. Putting the value for this in this equation of delta G naught will give us the value for delta G naught as delta H naught, we know it is 82,000. Temperature is given as 500 degree Kelvin into delta S would be 2 into 175 minus 245.4. When you do the calculation, we are going to get the value as 29,700 joule. Now, moving forward, we can calculate the value for log Kp, that will be equal to delta G naught is equal to minus 2.303 RT log Kp. So when you substitute the values over here, it is going to be minus 2.303, R value is 8.314, T value is 500 into log of Kp. When you do this, you are going to get this as minus 9573.571 log of Kp. We know the value of delta G naught, which we have calculated in the above step. So this we will equate this to the delta G naught value, which is 29,700 is equal to minus 9573.571 log of Kp. From this, we can find the value of log Kp is equal to minus 3.10. So Kp will be equal to 10 raised to minus 3.10, which comes out as 7.94 into 10 raised to minus 4, which we can substitute and write it as 8 into 10 raised to minus 4. This is the value for Kp. Now, once we get the value for Kp, we can find the Kp value as Kp is equal to partial pressure of Br raised to 2 divided by partial pressure of Br2, which is going to be equal to, as we have calculated already the number of moles for this, that is 2 alpha into 40 the whole square, the whole divided by 1 minus alpha into 40. This will be equal to 4 alpha square 40 into 40 divided by 40. Why? Because in the question it is given that this value alpha is very much less than 1. Therefore, we can write 1 minus alpha is equal to 1. So when you do the calculation, you get the value for Kp as 4 alpha square into 40. Once you get this, what you can do, the one which you got in the initial step, that is 8 into 10 raised to minus 4 for Kp value, can be substituted for this, and you can write this as 4 into 40 into alpha square. So when you do the calculation, it comes out as alpha square will be equal to 1 upon 20 into 10 raised to minus 4, which will be equal to 0.05 into 10 raised to minus 4. Once you get the value for alpha square, alpha value can be calculated as square root of 0.05 into 10 raised to minus 4, which will give us the value as alpha is equal to 0.22 into 10 raised to minus 2, or you can say that alpha is equal to 2.2 into 10 to the power of minus 3. So let's see if this answer is there or not in the options. If you consider the option number 2, which is nearly equivalent to 2.2, will be the correct answer for this. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.